So today we're going to continue with our discussions on linear time invariant systems. Okay. So last week we mentioned how to describe the input-output relations of a linear time invariant system using its impulse responses. Okay. So in particular, if you are given the impulse response of a system, let's say either h of t or h of n for a discrete time system, then you can express the output of the system as a convolution between the input signal and the impulse response. Okay, so the convolution is basically the integral of one signal times the time reversed and shifted version of the other signal. Okay, so by the formulas up here, you can see that as long as you are given the impulse response, you will be able to completely characterize the input and output relation of this linear time invariant system. Okay, therefore, we can say that this linear time invariant system is completely characterized by its impulse response. Okay, so if you want to specify what linear time invariant system you have, it is sufficient to specify the impulse response of this system. Okay, but note that this is only true for linear time invariant systems. If you have a nonlinear system, then this is not true, right? For nonlinear systems, different input-output relations may give you the same impulse response. Okay. All right. Now, while focusing on linear time invariant systems, we know that we can characterize the input-output relation. Okay. So we know that we can characterize the input-output relation completely using the impulse response. So the different properties that we described for various systems before should also be able, we should also be able to characterize these properties of systems in terms of certain properties of their impulse responses. Okay. So again, because linear time invariant systems can be completely characterized by their impulse responses, therefore the different properties of these systems can also be described in terms of different properties of their impulse responses. Right. So last time we started out with this system with or without memory. Okay. So recall that a system is memoryless if its output at any time depends only on the input at the same time. So if you write out a general expression for the input and output, you see that this summation here should have only one non-zero term corresponding to time n. Okay, so this implies that the impulse response h should be non-zero only at time 0. Okay, so you can write the impulse response hn as some constant times a unit impulse. Okay. Now, if you consider the special case where this k is equal to 1, then this impulse response is just equal to a delta function, and this gives you a identity system, right? This gives you the impulse response of an identity system, because if you take any input and you convolve it with an impulse response equal to a delta function, what you get at the output will be equal to the input. Okay, so an identity system is a special case of a memoryless system.